welcome to episode 3.A. Here I'm going to talk about the integration factor method for finding solutions to the following non-homogeneous system of equations. So, the way we want to think about this is you want to introduce a integration factor mu. I should probably write this a little neater. Mu of t. So this is supposed to make this equation easier to solve because we want to have mu of t. We want to basically write our equation in the terms mu times y prime equals, well, that's going to be u prime y plus u mu y prime, right? So if what we're going to do is we're going to actually multiply mu to both sides of this equation. So I'm going to go mu y prime plus mu py equals mu g. And so you want to bring the entire left side. Okay, you want to bring all of this into one equation. How are we going to do that? So we wanted to describe, we want this left side to describe, this. Or better yet, this guy, right? So how are we going to do that? We have this. If we want to do that, we basically want to say that mu times p, or mu times py, okay, is equal to u prime y. Because here we have this guy. So this guy, or I'm going to draw it in matching brackets, but this guy matches with this guy. So that implies that this guy and this guy match, right? So that's where this comes in. Now, what are we going to do with this? What are we going to do here? Well, what we can do is we can solve for u the same way we solved earlier. This is going to give us so we divide, we have u prime, we divide by y, we get p is equal to mu prime over mu. And well, we can solve this. This is going to go mu is equal to e, exact same thing we did earlier, dt. Okay, so now we found mu. And now all we want to do is we want to basically write this, now that we've kind of turned this into this equation, mu prime, mu y prime is equal to mu g. Okay, now what we want to do is we're going to differentiate. So we go, okay, mu y is equal to this integral of mu times g of t dt, and then y is equal to 1 over mu times the integral of mu of t times gt dt. Does that make sense? Right, and if you notice, since mu is equal to e to the power of this, well, 1 over mu is equal to e to the negative. So what do we get? Well, we end up with the exact same equation. We end up with e to the minus pt dt times the integral of e to the integral of p t dt gt dt plus c, right? And this is the exact same solution as we got earlier, right? So hope that clears that up, and that's another method, another way we can think about solving that. So I think I'll do a few more and then we'll move into the physics side, because this kind of idea of knowing how to solve differential equations is going to come in handy once you actually start talking about change of variables and different coordinate spaces.